meeting, and unfortunately, like I said earlier, one of the events pulled out, one of the sessions pulled out because of family problems or work commitments. So unfortunately, the session about reaching net zero with AI is unfortunately not going to happen. So our session is going to be a little bit more in depth, and we've got two use cases. But thank you for taking the time to come today. And yeah, I'll let it give it over to Rav.
Thanks, Marcel. Hi, everyone. I suppose all of you have been here at the Reactor. Is anybody here visiting for the first time? Okay, well, not. I remember you, sir. You come for a lot of meetups. So just, like a bit of housekeeping rules. Before we get started, toilets are opposite this door. Grey doors, double doors, toilets are through there. Fire exit is through there as well, so please follow the green running man. Before we get into the session, please take a moment, obviously, to read our code of conduct. We're all here to learn, so please be respectful, please be kind, ask a lot of good questions, but also respect each other's opinions. And I think we'll have a break around 6:45 for food. And if you need any further information about Reactor or what we do here at Microsoft, me and my colleague George will be outside at the reception. You can come and speak to us. But with that, I'm going to hand it over to you, and you can take it from there.
Yeah. Thank you very much. So welcome to our session, OpenAI meets Azure DevOps. My name is George. I'm cloud lead engineer at Expert Solution in Switzerland, in Baden. I'm almost 10 years in this kind of industry and building solution using Microsoft technology. Acquired down the road a couple of Microsoft certification, and last year also become a database champion in the industry. And together with Marcel, I'm going to present the two demos today. So Marcel.
Alrighty, hi there. My name's Marcel. I'm a DevOps MVP and also a DevOps and Solutions Architect. I work very closely with George and the Expo Solution Group in Switzerland. Thanks, George, as well, for going all the way from Switzerland today to help present this session. Hopefully, you'll be able to learn something cool today. And yeah, so basically, we're just going to show you some interesting things that you can do with AI. It's going to be a little bit more focused on Terraform and infrastructure as code, but just to say that the concept of what we're applying here can be used in other situations as well. So infrastructure code, like with ARM templating or with Bicep template, but our demos and things will be mainly around Terraform, and George will explain, why we're doing this and in more detail and go into the use cases and business side of why we're doing this.
Yeah. So setting up the stage. Question here is more about how do we come up with this idea of combining Azure DevOps, OpenAI, Terraform, and other Azure services in this area. What is the motivation? And to understand a little bit I'd like to introduce to the team that we are working on. So our team is the cloud infrastructure team inside Expo Solution. We are providing solutions for trading systems inside energy trading company, and as the central team, we are acting more like an enabler for other business application teams to develop their application. If you think about more like a team of athletes, right? If you want to train a team of athletes, send them to Olympic Games, for example. You might want to invest in training facilities to send them. You want to have diet for them, very good coach. You hire very good coaches, right? And think about it. Imagine that when it comes to compete, that athletes just stay in the hotel, right? Instead of going to fix the medals for you, they're just sitting in the hotel. After you invest so much time, money in their preparation. What is the analogy here? The same happens also to your application. Or maybe to your machine learning models. if you don't meet production, it doesn't mean anything for your application. And for meeting that production level, you need to have a very strong fundamental, and this is where the cloud infrastructure team is coming into place to deliver you that fundamental for your web application, for your machine learning to meet the production. And being a cloud central team, we have different role in our team. It is this part in the middle. We have DevOps engineer. We are having containers engineers, so the people that are focused on the Kubernetes part. We have application engineer, the teams that are more experienced in developing applications. And this is just a stakeholder map, just to show you how much interaction is between this central team and different stakeholders. For example, with the business departments, our cloud leads are responsible for taking the business requirements and translating those business requirements into some technical solutions. And then our team it goes more onto the technical part. We have to talk about with the networking team to establish firewall, DNS. We have to talk with the solution architects who are delivering us the target architecture picture. After we deploy the infrastructure, we need to think about how we can operationalize our solution. This is where the operations team comes into place, right? Production ready environment. And we also have to talk with data center team, because not all applications are already migrated to the cloud. And this is a complicated journey, and it will take some time. From the downside, of course, security is very important. On the other side, security is coming to us and say, hey, for this environment, we need to reach security risk score 80-85%. For this, you have to do this and this and this. This also impacts our productivity here, productivity of our cloud infrastructure team. And we thought about this, and with this migration of all the application, we cannot scale just by hiring new people. And to provide more value, we thought together, with Marcel, how can we do better on this part? What we are missing here? How can we deliver more value? And in the end, basically, we'll reduce how to reduce the time to market for the application. Because this is what it matters, right? To reduce the time to market. And with this solution right now, we started on delivering application like 6 weeks, the infrastructure part. We started with 6 weeks for one application. And with infrastructure as a code, we managed to reduce that time to market for the infrastructure. But we are still missing something. Then we thought, how about create some products and enable the team, the developer teams, to deploy their own infrastructure. Right? Of course, offering some training, how to use the platform, and to onboard them on our platform, and using the standards that our platform is offering. A self-service platform that can be used by the developers to deliver the infrastructure. And how does it work? So basically, this is the missing piece. And we developed a platform called Dias. It's design your own solution. And there are two options basically for an application team. Using Dias as self-service, and this will speed up the deployment. If you are doing right, and after our training, you will be able to deploy your infrastructure in 3 to 4, 5 days, depending on the complexity of your use case. But this requires a little bit of investment to allocate time from the developer teams to have 2 days of training, for example, with us. The advantage is that you don't. After this, you are independent as developer team, and if new use cases or new features for the application are coming into place, you are able to deploy it by yourself independently. The second option, let's say that the application team doesn't have the required know-how, or maybe the required capacity in the team. And for this, we said, okay, we are doing it on your behalf, no problem, but we are doing it based on our backlog, on our capacity, on our schedule. And this worked very well until now, but we thought about this and challenged a little bit the status quo. This is the status quo. We challenged a little bit this and thought about how can we do it even more flexible? How can we do it so that not only the developers can deploy their own infrastructure, But some teams with basic know-how in Azure can deploy a simple architecture picture that they have, maybe equal a storage account and a couple of other resources, without having to know all the complexity behind your network, behind DNS, behind private endpoints, and all the security policies that are in place. And this service platform is, at its core, it has Terraform. We created the modules for every resource, with the modules behind the platform. And that modules incorporate also the security mechanism that CISO, for example, is needing, and comes to us. Hey, we have some policies in place. These policies, you cannot deploy this without having a private endpoint, for example, private connectivity. This also is incorporated into the code. So we are trying to abstract all of this complexity from the developer teams and from the application teams. And we come with this idea.
Sorry, and just also things like the naming convention and things like that as well. We try and abstract as many things by building these modules with the security guardrails around it, including
Actually, Marcel is the product owner of the platform. I have him in the team together with Arinam. So we challenged a little bit the status quo and come up with the idea to use a little bit more of the data that we have it right now. So if you think about it, how much data we have it in Azure DevOps in the repositories, it's pretty much volume, and we can reuse this. We have in Azure DevOps not only the Terraform files, the modules itself, but we also have the wiki, the documentation of our self-service platform. We are basically in the README files. We have the Terraform code of how to use that module. What kind of, and you also get some examples how to use that module as developer, right? We try to make it more simple, more efficient for the developers. And we thought about this. How come we are not using this data, extract this data from Azure DevOps, put it in a storage account, put some LLM on top of it, and try to generate, in the end, based on the data we have it, the YAML pipeline, the ready-to-use YAML pipeline, based on this information, based on this example, and the YAML templates that we provide. So if we look at this data, it's not only about the modules, but we also have, for example, this is how we are using it. We are giving all the information. But think about it, how the YAML template, which is the pipeline, is structured, provided as an input. And working with Terraform, have you used Terraform? So you basically know how Terraform works, right? You'll have, when you deploy the first time, you deploy it, it will create the plan, it will create the state file, and this is your environment, right? Terraform plan, the state file is basically the same. So the next time, in the plan, it will be added the new resources, and you will have a delta. And based on that delta, Terraform will deploy the new resources or the changed resources accordingly. And this is stored also in Terraform files. Think about what kind of information, what valuable information you have from the Terraform plan and in the state file. So you basically can compare using some LLM models. You can compare the state file and say, based on the state file, please add a new resource to the YAML pipeline. So this a little bit about the vision, what is behind of it.
Yeah, I just want to show as well, like in this README file, this is basically an example, like George said, how to use this module that we built with those security guardrails and naming convention and things, mandatory variables, you could say almost. Where, for example, you see we use project name, environment, subscription. We're not saying to the developers, give us a name for your thing. We just say, give us your details of your project, and then we're constructing that name. And I don't know who here knows about Azure Verified Modules or has worked with Azure Verified Modules, but basically our modules building blocks are they're consistent across multiple repositories. So if you build a storage account, if you build a key vault, if you build a container registry, we always have the similar sort of structure, and private endpoints are built in. The project name, the naming convention is kind of derived from variables that we ask. But yeah, so basically those details are all in these README files. And I guess what we're going to show you next is how we can use this data in AI. So I'll give that back to you, George.
Yeah, so coming back now, we have this background of the information. Coming back to the architecture picture and the solution that we're going to show to you today. This is our target architecture picture. This is what we want to achieve today. So basically with the information that we have it on the Azure DevOps, the Terraform files, the READMEs that we showed, we'll extract that information using Azure Databricks notebooks. We'll extract that information, that unstructured data, and we'll write to a storage account. And we'll present to you two use cases. One of the use case one, is more code-oriented. The second one, use case 2, is more oriented to presenting how to combine the Azure services in this area. For example, Azure AI Search, Azure AI Hub, and at the end, we'll show you how to deploy the LLM application to an Azure App Service so that you can interact with natural language with this application. And we'll have some tests together. On the use case 1, on the other part, we'll use, again, Databricks to connect to the storage account, to the raw data. And we have to transform a little bit that data. We will use LangChain and ChromaDB. LangChain is, have you used LangChain until now? Yeah, heard about it? Yeah. So basically, LangChain is a framework, LLM framework for orchestration your LLM application, inside your LLM application. So what can you do with LangChain? For example, you can orchestrate two different LLM models. One will, for example, generate text from your picture, and other will use it for prompt or querying, for example. So there are a lot of LLM models on the market, and LangChain is basically helping you with their orchestration. As you might know, you might be heard about vector store database. Basically, with database and LangChain, we'll transform the data into embeddings, and we'll store this into a vector store. The vector store database choose for this use case is ChromaDB, but you can use whatever the vector store you may want. I just use ChromaDB because it's a light version, and for this demo, it's enough because we don't have big amount of data. Please.
Sorry, just a quick question on LangChain. Is it similar to PromptFlow in Azure AI?
Yes, it also incorporates prompts and PromptFlow. Yeah, but it's a little bit broader. You can also create retrievals. You can also create agents with that. We will show in the example a little bit. And then we'll use an example of how to retrieve that information from the vector store and OpenAI to query that. We'll do some queries together.
Yeah. Just to repeat the question, just for the people online, the question was, does ChromaDB, LangChain provide similarity to PromptFlow in Azure Hub? So that's just for the online audience. That was the question. So I just wanted to also say that before we jump into the demos here, the whole purpose of this is to basically, in the end, get the developers to have almost like a personal I would say co-pilot
yes.
for the Terraform code and infrastructure as code based on our data. So not data from the internet. So for example, you ask ChatGPT, build me a storage account. It's just going to go look in the internet, build a storage account. It's not going to use our naming convention. It's not going to use our security principles and guardrails. And the solutions that we're going to demo in these use cases are basically how we're building those co-pilots using our own data and documentation, Terraform plans, and things like that. Yeah. So
this is the advantage that you use general knowledge from the OpenAI, the general knowledge, with the knowledge that we build around developing our own modules.
Yeah.
Because if you just take, as Marcel said, if you just take a model from internet, it will just crash. We will not work on our Azure environment because of the policy, security policies, networking part, DNS, everything that is in between.
Sorry, just another quick question. So we're essentially doing the same thing, but one is using the Azure stack,
Exactly.
and the other one is just using.
Databricks, yeah.
More code-oriented. The use case 1 is more core-oriented, and the use case 2 is using the Azure out-of-the-box services that are right. So for the just to repeat the question was if the two use cases are similar. Yes, they are. Use case 1 is more code-oriented. It gives you basically more flexibility. On the use case 2, you can start right away using the Azure services out of the box, because everything is seamlessly connected to the Azure ecosystem.
Yeah. So the demo, we're going to extract all the files from DevOps into a storage account, and then we're going to use that use case 1 with that data, which is our data, and the second demo will be the same data using a second use case using Azure Path services. Yeah.
All right, so let's jump into the first demo. Between the use case 1 and use case 2, so between the demos, we'll have a small break. We'll have something to eat, some snacks, and then we'll continue with Marcel showing the demo. So the first demo, let's jump into Databricks. I will show a little bit, present you a little bit the environment. So the Azure portal. So what we have here in the resource group is basically the service that we are going to use for the use case 1, the Azure Databricks service and the storage account. For the storage account, we will pull out the data from Azure DevOps. I will just create here a new container. And I will navigate now to the Azure Databricks workspace. Have you used Azure Databricks until now? In which use case? Because Databricks is a platform.
A long time ago, so nothing as fancy as what you're doing.
But more on the data analytics part, so data engineering?
It's mostly data analytics.
Okay, no big data and...
No, just messy data.
PySpark?
No, SQL back then, nothing as fancy as back. Yeah, just a lot of queries. Too many queries.
And how it went? Were you happy with the product back then?
I wasn't happy with the numbers because it never quite added up. Like big queries. The product was good though. Database was very useful.
Yeah. Actually, they evolved pretty well last years. So this is our environment, Databricks environment, the workspace. Basically, Databricks is an analytics platform, right? You can do data engineering, extraction. This is also part of data engineering. You can do your machine learning use case on it, right? And you can also build your own SQL warehouse. Right now, for example, they have SQL serverless option that you can basically put your data in, and then on top of it, Power BI and create your dashboard. So it's an analytics platform. You can do a lot of things with Databricks, but today we'll focus on the more on the engineering part and the notebooks. So basically here we have the menu, but workspace is where your notebooks reside. This folder, Season of AI, and here are my notebooks. But just to navigate a little bit to the other parts, for example, for the SQL part, you'll have here the options to create a SQL warehouse. It's working very fast. It's a serverless, so you don't need to take care of the infrastructure behind of it, as it takes, and it actually pretty fast. I tested in a couple of solutions, and then from here, the SQL warehouse is pretty easy. You have the connection details, and these are the connection. You can pretty fast open a new Power BI and have the dashboard there, pull the data in your dashboard. This is the SQL part, the data engineering, where you can also orchestrate your job and integrate data. I use this part, the data engineering part, in the past. I use in more combination with Data Factory, for example. I use Data Factory for orchestration of the solution, but the Databricks, the transformation of the data, the cleansing of the data, put it in the notebooks, and trigger from the Data Factory the notebooks from here. And machine learning part, you can pretty have your experiments here, your models. And important here also offers you at the end a service endpoint for your email that you can integrate it with other applications. Going back to the workspace, we'll get to our first part. So this part. So my cluster is already started. It's already one. If I go to the compute power, you have here my cluster. I choose for this use case the Databricks runtime version with ML capabilities, because this offers me.
So sorry.
Yes, please.
We can't see your screen on.
Yeah. Okay. What can I do?
So we might need to.
Share.
Yes.
Okay, let's try.
Stop screen. Stop screen.
Stop screen.
Yeah, and then present again. Screen. Screen. Yes, and then if you go back.
Okay, thank you very much. Yeah, so about the cluster a little bit, I choose this Databricks runtime version, ML capabilities, because it already comes with a couple of ML libraries pre-installed, but together we'll also install the libraries that we need so that you can see what I've used. You also need to be a little bit careful, because in this environment, everything is happening very, very fast. So the updates of the libraries, they're releasing new versions very fast, and some of them, they might be from today till tomorrow deprecated. For example, doing this demo, it happened to me also. So going to the workspace, we'll do the first demo with the readmes. So basically, put here again the architecture picture. We are on the first step, where we want to extract the data using Databricks and put it in this storage account, the storage account that we created before. Check once again the name, the container. So let's create this one. Data. So we have our container here. And I'm going to install this library. Some requests. Until this is installed, I'm defining here my path, data. So the container name is data. I'm using Databricks stickers to read the stickers that I need, the DevOps path token. So we are going to use Azure DevOps API to extract the data and to save it to the Azure storage account. And this secrets is basically the key vault of Databricks. Right? I use Databricks CLI to store the secret in this DB utils. Use this decoders for JSONs, so for text data. And here I have defined a function that is reading basically the repositories that we have it in the Azure DevOps. It's looping through the repositories, because in our Azure DevOps, every module is a repository. Modules are repository, and then you have branches, and we develop branches. So this is my function for getting the repositories, and then I'm fetching here the README content with this second function. And if I want to print some content, for example, I passed here the values of Azure Key Vault and print the README list. This is how it looks like. It's Markdown language, but we can still sense here that, okay, this is the right modules, for example. These are the variables. And this is exactly the Key Vault that we have in our Azure DevOps. So I just print it here. But the next step is with this function, I define a function to save that information to our storage account using the path that we define it. And here is where I basically put here the README. But you can do the same also for YAML and for the Terraform files. And here is where we actually getting the data, fetching the data and save it. So we are calling here the function that we defined before. And this will look something like this. So here route. So this is where every file is written.
Just wanted to quickly say, when we're extracting the data, we can take also not just the README documentation from our repos, but also like Terraform plans. Any sort of data that is resided in the repository can be extracted. If you have that data, it's all right.
Yeah, sure. If you using Azure DevOps API, you can extract a lot of more information about who released this module, or when was the last time, what is the version. So you can be a little bit more flexible.
Yeah.
So let's check a little bit storage account. We should find some data inside of it. Yeah, here the README files. And if we just explore one of them, doesn't matter, container app, edit. So it says here, these are the README files where it gives you the overview how to use that modules, which variables do you need, and so with this, we basically achieve the first step here. And we'll move to the second step, which is more interesting actually, where we take the LLM part. Let me navigate to the other notebooks that I've created. So the same architecture picture, of course, and I have to install this library. We can also do it before on the cluster. But I want to show it to you what kind of libraries are relevant for this use case. I just upgraded LangChain. I have to restart. Again, I will use here the same function to extract to fetch the secrets that I need. And one of the secrets is this one, the OpenAI key. You can get it from your account, OpenAI account. And here we're basically defining our first interaction with OpenAI. So what I've defined here, the LLM model that we are going to use. So this is the latest one. And I'm saying here, I'm instantiating OpenAI and saying, please use this OpenAI key with this temperature. You know what this temperature is actually? It's basically telling you how creative the LLM model can be in the end. it's a value between 0 and 1. And if you put 1, it might be too creative. Let's put here for our use case 0.3. So it might hallucinate. It might make up things that are not there, and we don't want this because this use case is not about the creative part. It's about more retrieving the information that we actually need, right? And just to exemplify this, we'll invoke this and say, hey, what is Terraform? Just a very simple, basic example, and we'll print the results here in.
Why do you have another temperature? Is that a different temperature in the chat model?
Yeah, this one is using 0.5. On this one, I just instantiate another one. This I will use it after this. I will use it in combination with our data. That's all. But for this one, yeah, if I put here, let's put 9. This will be used here in the results. So it should get definitely in provision. So this is how the content looks like. From here, you can also extract more information, like, for example, what's the model used for this one, the ID. You can do some metadata information about this. In the next step, I will install this library. This library is helping me to tokenize the text that I'll give it as an input. It works very well with OpenAI language models. So it's not TikTok or how this subject is called. It's just the library that's. We're not staying. Next, we will test the embeddings. So we'll import here the OpenAI embeddings and this text splitter. This is the command where we are instantiating basically the embeddings, and we'll have 3 options here. The first is, as prompt, we are using Terraform to deploy infrastructure. Math is my further subject, and Azure, we can, in Azure, we can also use ARM or Biceps. These are 3 statements, right? But there are some similarities between these 3 statements. Of course, it's a very simple example. You can sense that the first statement have a pretty much similarity with the third statement. Yeah? But this is how it basically works with embeddings. It's just transforming your data into numbers and then find similarities between them. And to exemplify this, we created here this similarity variable, and we just compare with this NumPy function. We compare the similarities between Terraform and Azure for it. And when comparing this, we will get a similarity of 80 around. If you put math, then you should expect a little bit less. So this is how embeddings are working with similarity. You can also use other ones, but for this one we use similarity. The next step, we want to load the data that we saved in the README files. I will just choose the MD, the Markdown, the READMEs, not the YAML pipelines. Of course, you can also do this, but for this purpose, for this use case, we use the Markdowns and READMEs. And for this, I'm reading with Spark. I'm passing here the source file, the source path to that files, and then I'm doing some transformation on the data so that I can I can read it in the human readable format, and then I print some content. Some time to explode this part here. So this is how it looks like. Every file will have it here. And the next step will be basically to split that document into chunks for efficient processing. But we need to be careful that because we want to preserve preserve context between the chunks, right? So what does it mean? Basically, when we define the splitter using this function, we'll have a chunk size of 1,500, for example. Right? So it will start with 0 till 1,599, and then it says here the next parameter is chunk overlap, and it's starting with 150 before the first one ends, so that we have an overlap between the chunks, so that the large language model doesn't lose context. Because if you just start where the other ends, we lose context, and this is how it creates a chain of thoughts. Basically, this is how it creates a chain of thoughts. So this split is very important to have this chunk overlap, and with this value you can play a little bit according to the data. But basically, using the data that I provided, run it, it will split my my data into 443 chunks based on these parameters that I give there. So very important to not lose context between the chunks. The next part is where we use our vector store. For this, I'll have to install the ChromaDB. Some of the libraries are already installed. Until this is installed, the next part is where I'm defining directory to store that data, but you can also store put the ChromaDB files also on your storage account, so this is not a problem. It's not necessary to save that on the cluster, for example. And to create the vector store, I'm using the Chroma library here, and I'm saying here from the documents, use the split text, so the text that I split it before. I'm using the embeddings, and then I'm persisting this to the ChromaDB directory. And if I'm doing this, this is how my file looks like. So in this one, the file, the metadata files from ChromaDB. I just want to print the collection. Now I have double because I ran this before. So the collection is this one. Then the next step is basically to test it, to find documents content that is semantically similar to the query. We'll start with a very simple query. It's okay. Based on the information provided, what variables are necessary for using the module's container registry. So this is more an extraction. And for this, we'll use again this similarity search. And I'm giving here this argument 30. This basically means retrieve the top 30 most similar documents. You might, if you have a lot of data, you might need to be careful with this parameter because this will cost also will impact your cost. But for this use case, we'll use top 30 most similar documents. At the end, we'll print and say, okay, just return the first page of the content from the 30. It might be the case that he doesn't use all the 30 because the relevant content is only in the first 10 pages. And it always shows that from the first page, it extracted the modules for container registry, and these are the variables assigned for that. If I'm putting here the next one, so this is the length. So it used actually the all 30 or 30. This puts more use IDs, subnets. And that's how we interact with this similarity search. The next step is the retrieval. So how do we retrieve data from that vector store database? I'm going to use to create a retrieval here using that vector store that I defined earlier, and I'm invoking the retrieval here again with the container registry. Pretty much the same. And the next step would be to create an agent for this. So an agent is basically how you interact with your system, with Q&A, question and answer. And this is pretty much the phase where it generates the answers for you. And for this, you can have more than one agent. We'll see in the demo, we'll define basically 3 agents and see how the LLM application is basically choosing the right modules according to the topic and switching to the topic. It will basically create a chain of thoughts, where we can say, okay, for this particular task, I choose this agent, but for this one, I choose maybe the mathematical agent. This is how we are going to test next.
Just to come back to one of the questions earlier about LangChain. So this part is the where we're doing the LangChain. Just to answer that question.
So here I'm specifying the LLM with 0.3 temperature that we defined earlier. Chain type, we need to have this chain of thoughts in the end, and we define the chain type. You can have different variables here. Staff and refine, I tested them. Staff is pretty straightforward, so it's going to the solution pretty straightforward. Refine is trying to refine more a bit the solution, but it will also take more time. So it will iterate more and try to provide a more exact answer. But for this use case, we'll use Staff because it's going, it's more straightforward. It's going to the solution directly. And to see what the chain of thought is, we have this verbose true, so that we can analyze, okay, how did you come up with this conclusion? And with return source documents, it's basically also showing from which documents he retrieved that information. So let's create this Q&A chain. In the next step, I will create a function just to prettify the response a little bit. And now we can test a little bit our and they say the first prompt was, okay, what YAML pipelines do you have in the, it's not a very complex prompt, yeah, but you say I don't have any because we have just the markdowns, the README files, correct? And in the next step, I will create the agents that I talked about. I'll install this library for the number expressions. And import the libraries for chat prompt. And this is where I basically giving the prompt. This is the prompt template that I'm giving to the application. You are an Azure Infrastructure as a Code assistant, and you are tasked with taking a natural language query from a user and converting to YAML pipeline solution by understanding the modules and the pipelines that are provided to you. And here's the query. This variable query, I'll pass it later. This is just a placeholder there. And at the end, I say generate the YAML pipeline according to the templates provided. But for this one, we can skip it. I can take it off. And I'm instantiating the LangChain. And I'm creating the tool. Here is the part where I'm creating the tool. I'll create 3 tools. One is the search engine. That is basically using the general knowledge of OpenAI. Yeah? And I'm saying use this tool for general questions. But don't try to use this tool for answering Azure Infrastructure or Azure Services or any DevOps questions. The second tool is called Large Language Model Infrastructure. It is basically using our chain created before and it's using the knowledge that we provided into the README files. And the last one is just a simple tool for LLM math, which is just out of the box tool, just for math problems. So let's create these three. I think this one is already created. And then I add all the tools to this this list. And I want to print to see what kind of tools do we have. So the first one is the calculator, it's the math part, the math agent, and says useful where you need to answer a question about math. So it realizes, okay, this is for math. Translate the math problem into an expression that can be executed with Python. The next one is our language model infrastructure. And it's using the prompt template that we provided. And the third one is the search engine. So let's try to interact a little bit. And here I'm initializing an agent. And basically, you have three options. This zero-shot React that we see it here is for only single interaction with that agent. So it doesn't provide memory. If you ask maybe some question from the history, it might not understand because it doesn't provide any memory. The second one is the chat conversational React. This provides memory, but for this you have to, you had before, to provide a memory where to save that information, that context. And the third one is a hybrid approach. For this use case, we will use the zero-shot interaction and description. And yeah, let's try with a simple query first. I'm 35 years old now. How old I will be in 25 years? So this is a chain of thought. I think this is more important than the answer because we already know the answer. So how did you come up with that conclusion? Here starts the chain, entering new agent execution chain. This information is available because we put the verbose true. And it says, I need to calculate this one, and it takes action calculator. Yeah? So he realized I need to use calculator, the math for this one, and it provides the answer. Let's try the next one. This one. So in this one, I'm saying, please use or some YAML pipelines, deploy a storage account using the modules and take care of the rest of the variables. So the chain of thoughts here is a little bit longer. It is entering again the agent executor and says, oh, I need to use large language model infrastructure tool to generate the YAML code, because this is what I'm asking for when I define that tool, right? And as input, he takes here, create YAML pipeline for storage account using the modules. It's basically the observation that he took into account. I'm sorry, but the inputs he provided do not match so because we asked for YAML, right? And then the next, it enters, because it's a chain of thoughts, it enters the next chain. Don't have enough information. It says it's not able to generate YAML pipe. Let's try now with the storage account module. This is here. You see here action is you only can use these agents that we define it. enters the chain. And it says the name of the resource group. So it provides some information here. What kind of information you need to have for resource group of the storage account. So it's trying to retrieve the information. I've gathered the information on the necessary variables. That is the next chain. I need to provide an action input to complete require the next one. And then it says I have successfully retrieved the necessary information. The necessary variables for deploying are this one, and this one, with the source variables like account storage, etc., and etc. Basically, using the content that he provided here, you can extract the information that you needed from the observation, part, because this is the query, and the results is somewhere it's here. So it's a JSON. You can extract the results from. From here, you are pretty much flexible because you can use this to create your own web application on top of it. You might be exploring the use case of creating directly the YAML pipeline if you have the information there. I think the most interesting use case would be to combine the Terraform plan and the state. This might be a very good use case because you have the state of your environment, the actual state, and basically you can say, based on that state, just add another storage account to that solution, and it will create that module for you. Put the variable in, and from there you can take it to the panel. From here you are flexible. You can put also web application on top of it to interact with it. But we'll see this part with the web application on Marcel demo, how to interact. So this was my preparation for today, for the demo, first demo. I hope you enjoyed. And if you have questions, just let me know. I'm also on LinkedIn available. I'm free to speak with you and happy to meet with you. Thank you very much.
Awesome. Thank you. Thanks, George. Very, very cool. We're just going to take a small break. There is sandwiches and food at the end. We'll probably resume at about, I would say, maybe in 15, 20 minutes or something like that. We'll do another demo using the Azure services. But thank you. That was really cool, especially seeing LangChain, how you can chain different prompts and stuff. Was there any questions for this specific part from the audience?
Yeah, I guess I have one, which is,
Yes, please.
with much longer context windows, do you think that amount of chunking and embedding is still necessary? Do you have way over 1 million characters or way over 1 million tokens in your README files?
This is interesting. I think we need to explore that option. We need to have that information first, and we need to play a little bit with the parameters. Yeah.
We moved away. We did months and months of this and then moved away from it. Because
actually, I was not sure about the end results of this one, because even with the temperature 0.3, it's still making things up and generating new stuff, and the library is also changing. So it's more an exploration phase, and it also depends on the use case and the kind of data you have, how clean the data is, right?
Yeah, the more data you can give, the better it will be.
Yeah, and context windows are growing so fast that
Yeah.
a lot of what we've been using for the last couple of years is almost obsolete already.
I'll also show later in AI search how you can create schedulers for your indexers. So if your data grows, if you add more data, it schedules it and it grows your vector store. So I'll show that in the next demo. But yeah, any other questions? Is everything all good? But yeah, feel free to have some food and a drink and a refreshment, and we'll resume at about 7:30 with another quick demo. Thanks.
Thank you.
Awesome. Nice, man.
That's good.
Yeah. Very cool. Very good. I really like LangChain. LangChain is so cool.
Did I explain properly?
Yeah.
I didn't want to be too much.
That's going to us, actually.
Yeah, that's yours.
Okay. Yeah, feel free to grab some food, man.
Yeah.
We'll resume in another 10, 15 minutes or so.
Is he coming back? The guy who cancelled, or I actually came mostly for that. I've heard.
Tarun, I'm still organizing with them to do another
All right.
session. Yeah, it's unfortunate they had some issues with that.
Yeah, you said.
But we will try and reschedule that.
Right.
That session. Like, we won't be able to do it in the next session because that session's already full of speakers. But we might be able to juggle it around. But if you do keep an eye on our meetup or connect with me on LinkedIn, I can give you like the details.
Yeah, I'll just follow on Meetup.
Yeah.
Was it very technical, his talk, or was it?
It's more. I don't know the specifics of the talk.
Okay.
It was more like
I'll
as technical.
right.
Not a super technical talk.
I came I came for that. It was
Alrighty, so thank you everybody. Like I said, grab another sandwich or a drink, and I'm just gonna kick off the second session, the second use case to show how we can actually use that data as well to deploy to a web application where a developer can, ask it to basically build you your infrastructure, almost like a co-pilot, I would say. These are kind of the services that we need, and I'll go into these in just a moment. So as you know, we use Databricks in our first step to get the raw data, our README documentation and stuff like that. Now the problem statement is sometimes with developers and infrastructure, the developing team might not know how to build their infrastructure. They don't want to really read the documentation. Maybe they do. But we thought, how can we simplify that? Maybe create a co-pilot or something like that they can just ask it a question to say, build me a storage account. So I'll show you two parts to this. Like after the co-pilot is built, how it uses if you was to use something like ChatGPT without your own data, and then also using your own data, like I said, with those guardrails and naming conventions and stuff like that. So we've got all our data here into our storage account. Now, the next thing that we want to do, and you don't have to do this, so I'll just quickly jump straight into AI Studio. I'll also jump into OpenAI Studio. AI Search is another component that we'll use. And you see there we've got a key vault as well. Whoops, I think it's...
Let's use the first one.
Okay, let's have a quick look here. So AI Studio, Azure AI Studio is almost like a platform that you can connect all of your different bits and pieces to. And you'll see here that if you go into AI Studio, you can almost see the different AI studios that you have. You might have more than one in different regions. But if we go into this AI Studio instance hub, you can see here, you can set up a project. You can put connection, like sources of data. So if we say, for example, I want to connect to Azure OpenAI or Azure AI services. So the difference here between the Azure AI service and the Azure OpenAI service is the Azure AI service gives you models like Mistral. It gives you, the Microsoft ones, the non-Microsoft. It's got a big catalog of models. The Azure OpenAI service is purely for the OpenAI LLMs, like GPT-4, GPT 3.5, those ones. AI Search is also another connector, and what I'm going to show you actually is how we vectorize that data. But basically, you can set up your connections here. So I've set up a project already, and in here you can put in raw data, and you'll see here that I've when I do a new raw data source, I can tell it where is that data, where is those README files, those MD files, or those Terraform plans, or where is my data? So I can say, okay, it's in this storage account. In our case, we've got all our README documentation in the storage account. And then we can create an index from that data directly in AI Studio. But I'm not going to show you that. I'm going to show you how to create an index in AI Search instead. So if I just quickly jump into that, because it's very similar, and you can add that index into AI Studio also. So I'll just quickly show you that. So no, that's the OpenAI service, which I'll also show in a sec. So we've got our data, and now we want to index that data and vectorize that data. So we can add our data sources here also. So for example, let me just go to overview. I can go here into import data, for example, and I can say, use an existing data source. There's quite a lot, right? And in the previous use case where George showed how we can put that data into a Chroma DB, we can also put that data in from Databricks into a Cosmos DB, and then link that in AI Studio to do our vectorization. So you can almost combine the two use cases in a way. But what we've done here, or what I've done, is I've added the storage account. Now you can just import the data and create an index, or you can also vectorize that data. And the vectorization is interesting because that creates high dimensional space for efficiency and similarity calculations of the text. And you can actually use, like, let's say we pick our storage account, for example. Don't need a folder. Let me just see, that's the container was data. So here we can actually, because let me just quickly jump to OpenAI Studio as well, because in OpenAI Studio you have to deploy a model to use. And you get different models like GPT 3.5, GPT 4. So if I just go in here into deployments, you'll see here I've got a GPT 4 deployment, and you can use, there's GPT 4 Omni now that does text and visuals. And you also have the one called text embedding. Now, when you're vectorizing the data in AI search, you can actually use that model in OpenAI to use text embedding to vectorize the data and import it at the same time to create your index. I'm just going to exit out of that because I've got an index already. I just want to quickly go into the indexes. So there's my indexed data from the storage, the storage account. And you can have multiple indexes. You see there, I've got one for the READMEs, I've got one for Terraform plans. Maybe a solutions architect can say to the Copilot, can you explain this infrastructure for me? Or can you maybe describe the infrastructure? Because we've got that data in Terraform plans and vectorized, we can ask it that, and it will actually try and explain the different architectures. Or a developer can say, can you help me write my storage account, for example? Or can you help me write my infrastructure, my pipeline, whatever, because we've got all of that in the README index. Now, you can also set up what's called schedulers or indexers. I think it's here. So, sorry, no, not in this bit. Let me just quickly go into the indexes here, I believe. No, I can't find it now exactly. But you can set up a scheduler that will basically run. Did you see if it's in here? You can do that in JSON. Sorry, yeah, here's your schedule. So when you're creating an indexer, you can say, you can give it the index that you want to use, give it the data source, and you can apply stuff like skill sets to it. But then you can put this on a schedule to run, once, hourly, daily. You'll also get this option to add an indexer or scheduler when you're importing new data or importing vectorized data. So you have the option to index that data once, or once an hour, or once a week. And an example of this is, say, for example, your documentation keeps on changing, and you want to keep that Copilot, that assistant up to date with you can then set up a scheduler to kind of pull the latest data once you've put it into that storage account. So we've got our index already here. There it is. I'll just quickly go back to OpenAI Studio, which was this one here. And because this component we also need, like I said, you need to create your deployment. So we've got our data in the storage account. We've got our indexed data that we index using Azure AI Search, which is very basic. You just point to the storage, to the raw data, and you can set it up. And then we've got our model deployment, which we want to use, so GPT-4, for example, and maybe the embedding for the indexing. You can also now do visualization indexing, where it converts images into numerical vectors for similarity calculations. And there's a few pre-trained, they're called CNNs, which is convolutional neural networks, that can basically group vector space different images into a category and have similar images that uses a embedding. That's also in AI search. If you import and vectorize your data, you have this option to also add embeddings for images to basically use as well as text. So with that all in place, we've got, like I said, our raw data from the storage account, which we can create an index from. In our case here, I'm just creating an index, or I created an index from AI search, and I just added it in here. Just to jump back just real quick, when we're setting up this hub, these connectors, you see here we have a connector to AI search. Jumping back to this, we have a connector for OpenAI Studio, and we have a connector for blob storage. You can add and remove connectors here, but that almost connections to the different pieces and building blocks that we need is also linked with a storage, with a key vault. So Azure AI Studio is linked with a key vault. So when you add a connector, it will automatically add, so you have another instance of OpenAI Studio you want to add into as a connector, or you have a data source, maybe a storage account. You have another data source, which is a different storage account. You have maybe a Git repository. You can add those connectors, and all of those connectors goes into your key vault. So for example, you'll see here one, this one is, if I just make this a little bit bigger, you'll see that's the one for AI search, and that will basically contain the connections to the AI search service. That contains the connection and API key to the OpenAI service for the modules and stuff like that. So it's kind of cool that it has all of these connectors, and as you add and remove them, you'll see them populate a key vault or not. And it's just for the platform to understand where to get the data from. So just coming back to that, we've got our index, we've got our data. Now, just to show you also just a bit of the model catalog that comes with Azure AI Studio, because there's sometimes a bit of a confusion with the OpenAI Studio and the AI Studio. So the OpenAI Studio, like I said, is purely OpenAI models, whereas the AI Studio has got, it's got the OpenAI modules, but it's also got all these other ones from Meta, from Mistral, and I'm sure it's going to be combined soon as well. Anyway, so if we just look at the chat now, in the chat, because we've got our data there, you can put in your prompt here, like George showed earlier. You can say, I am an, could say in infrastructure engineer. Oops. Let me just put in there, infrastructure engineer.
I can copy from the.
Oh, have you got it? Oh, just beside to help write Terraform code and, I don't know, YAML pipelines maybe. Oops, I don't know this keyboard. Just, Terraform code, very basic, but you can have like quite intricate prompts and things like that. Now, I've not added my data to this chat playground yet, so I'm just going to ask it a question. I'm going to say, can you write a module for a storage account? And it's going to now use that GPT-4 connect. No, it's going to use the. Okay, so I've not really given it much in terms of. So I don't know what it's done there, but let me just try. And you write a Terraform module to build a storage account. Let's see what that comes up with. So you see there, it shows you what you need to do for the provider, how to write the variables, but it's getting this data just from the internet. It's not really getting it from our data that we want to use. It'll just use stuff that it's got out from the internet, and it doesn't really comply, to be honest, with our security strategy or our naming convention or anything like that. So what I'll do now is I'll add our indexed data, because we have that connector to Azure AI Search with our index already in it. I can just say, I want you to use that instead of just going out on the internet. And now if we ask it the same question, can you write a Terraform module to build a storage account Azure? It will actually say in here, if it comes up in a sec, it will actually say, based on the retrieved documents, I can help you to create a model to deploy a storage account. Now, if we look at that, sorry, my a bit frozen at the moment. There we go. If we now look at this, it's not scrolling. There we go. So now if we look at this, you'll see here that it's going to use, it's actually quite accurate. It's using our modules, the variables, and also you can see there the module that we have in our example file. And it gives you also a little bit of a description, and it also gives you a reference. So you can say, I got this information actually from this README file, which is really cool. Now, what do we do with this? Because we want now people to be able to access this data in their project, so we can deploy our project to a web application directly from the chat playground. So we can say deploy this to a web app, and I will just quickly launch that web app in here.
Sorry, Marcel.
Yeah.
Simple question. So when you have added your index, does it primarily just use the index as a reference, or does it also use some of the LLM's internet knowledge in generating?
So the question is, when you're using an index, does it also use other data sources? Yeah. So you can add multiple data sources, but it's still your data. Like, it will not go, the large language model is just for you to help to interpret the data and to index the data. It will not go and, but also that's why you have the temperature as well, but it will mainly use your data. This is what is important about it. It will use your data. And you can set it to say, if you cannot use your data, then you can go out and look. There are settings for that also. But you can have multiple indexes, and this is in the AI Studio, where you can have those multiple connections and multiple indexes, multiple data sources for your data. So I'll just quickly show you the web application, because I've already deployed one earlier. So like I said, from the components, we've got AI Search, we've got OpenAI Studio, AI Studio which is kind of almost like the central point. secrets are stored in Key Vault. Data is being retrieved from Databricks to storage. And then essentially we end up deploying this web application. And if I, that comes up in a moment, hopefully. Okay. Seems to be a little bit slow at the moment. Just to load that. I think the internet is not playing ball. But so just to explain, it's basically, here we go. Sorry about that. Took a little bit of a moment there. Think about it. So that should load up as well. Just a moment. Is there any, just while this is loading, is there any questions or any other questions about what I've been showing here? Okay, good. That's good. Should upgrade my SKU really, or maybe it's the internet connection here. I'm not sure.
It's an internet connection.
Hopefully it'll come up. But yeah, it's all it is. It's just like a little website with a chat box, and you can ask it the same questions that you would have asked them in the chat playground. But what's nice about it, it's a web app which you can give the URL. You can protect that URL, give it to your audience. You can have different web apps for different projects, for different teams. You can have different, like I said, in AI Hub, in AI Studio, you can have the different projects. Those different projects can be linked to different data sources for those projects. And then you can have different web applications for the assistance for those projects or architectures or whatever it is that you're using. Let's try one more time. If that does not come up, then let's see. Oops. No, that's coming up. But yeah, I mean I guess that concludes my part of the demo. Yeah. If there's any other questions, then just feel free to come to me. Like if there's any questions outside of this, just come and ask me afterwards. Yeah, and I guess that's the end of the demo. Really, thank you very much, and thank you everyone for coming. Thanks, George. I guess we'll just do our closing slides. Give that over to you. Close those ones. I don't know what it's doing. But yeah, it just gives you basically a nice web interface of this screen. Just seeing that.
You can deploy that to an app. I saw, right? There was a tab for that. You can deploy it to an actual app.
Yeah. And you see there it says deploy to web app, and it will actually build the app service plan and deploy to that.
The option to.
Oh yes, yeah. Here's the different options. So you can create a new one or use an existing one of your data. It's pretty cool. It's a shame I can't show you what it looks like there, but it is very basic, just chatbot. Yeah. I think it's a bit slow. I think it's because of the either the SKU maybe. Oh, here we go. There we go. There we go. IT support. So yeah, so we can
open a ticket.
So you can ask it basically. So it looks very basic, and I mean you can customize this if you do web front end customization. But we can ask it the same question basically. Say, write an example of how to deploy my storage account. But because we're working with our data and we educate our developers that we don't do a naming convention, we could say you use your project name and your subscription, for example, to generate the name. I can say even here my project name is, say, Orion, for example. And it will go now and interpret that data or that question. And hopefully that won't take too long to come back, but it will basically have that same result as earlier, but it will use the actual, it will try and populate the data as well, the variables and stuff like that with this extra information that I've given it. There we go. So you can see here now it's telling me create a resource group and then create a storage account. Oops. And it actually shows you the, actually this is not, let's see what's the reference here. Yeah, so it's using our data basically to generate this pipeline and
using the module.
And basically this is what our module would look like. And I can say, what about a container? Container.
Does this interface do a bit of spell checking, correction?
It will interpret if you write the wrong word or maybe a letter long, it will interpret the right word. I might have to add a few spelling mistakes as well in there. So you see again, it says, given the information from the documents that I've retrieved, this is the project name.
Actually, that prompt that you give it there, first it's embedded, it's translated into embeddings, into numbers, and then find similarities. So if you just put another letter spelling problem, right?
Because it's character-based, right? Your embeddings are character-based.
Yeah.
And so you can see here that it's using our variables from our documentation, and it also gives you an example of the module, how you would use that in, and it even tells you how the naming convention is structured. So you can say what would be the name of my container registry if my project is Ryan, for example. And it will try and it kind of helps. It's basically like just an assistant for developers to kind of build their own infrastructure. So you can see here that the subscription, so it tries and guess what the, it guesses that you are a subscription type of P. We have P and NP for prod and non-prod from our documentation. Project name would be Orion. Environment could be prod, dev, QA, whatever you want. And then it will even actually calculate what the name would be, because we don't generate the name. We don't ask the user to input the name. We just say, give us a project name. And we do that abstraction of naming conventions. So, but then that helps cause confusion where a developer go, oh, I've deployed a storage account, but I don't know what it's actually going to be called. I mean, in our documentation, we do say the naming construct, but this also kind of helps, right? Because it's now a bit more personal, where you can actually ask and chat to it, and it will basically give you that information based on our data and our documentation. It's kind of just very handy for developers, I guess. But yeah, I guess that concludes the demo and what I wanted to show you. Got into the web app eventually. So yeah, I'll get George to also just close up for us with the with the closing slides.
Basically, it's more about balancing the we talked in the pod to balance the this temperature and to see how long can you or how long can you say this is my data and this is the data coming from the knowledge part. How much do you want to balance between these two, right? Because if you start doing too much from the general knowledge, it might become up with hallucination, and it depends on the use case. You might want to be creative, but in some use case you might don't want to do that. So it's more an exploration part to find what is best for your use case in the end. Basically, with our solution, we are trying to democratize the self-service platform, the options of deploying infrastructure into Azure, to democratize it inside our company and say, okay, if you have this kind of skills, maybe then you can deploy your own infrastructure independently, rely only on our schedule. We are right now. This is where we are focusing. Well, thank you very much. This was the closing one. And yeah, if you have questions, just let us know. We are also on LinkedIn, very active, me and also Marcel. Let us know. We also send you the slides after this. Yeah, thank you for joining.
Thank you. Also, sorry, I just wanted to also thank the wider part of our team who couldn't be here, like Arindam, George, obviously, Anand, Alberto, Lopez, Jaime, Mario, Carlos. They're all part of the same team that's made this possible, this self-service. Unfortunately, they can't be here, but big thank you to